Hi everyone. In today's lecture, we will be solving fundamental problem number 9 of chapter 2, force and vectors. In this problem, we will be determining the magnitude of the resultant force acting on this carbon, and we will be measuring its direction measured counterclockwise from the x-axis. We have three forces F1, F2 and F3 respectively, so we will be determining its resultant force, and also we'll be determining its direction measured from this x-axis counterclockwise. I'm assuming that if our resultant force is acting here, so I need to find this angle. So if this is the resultant force, I need to find this angle. So this angle will be termed as theta, which is measured counterclockwise, means anti-clockwise in this pattern. So we need to determine two things in this video. The general step for the solution of this question is almost same as compared to the previous lecture. So the only thing is different. We'll be measuring the direction counterclockwise from the x-axis. So this question basically the amalgamation of cos theta, sin theta, and similar trigonometric technique. We'll be using all these in the same lecture. So moving to the solution of this lecture, first I will be resolving its x and y component for F1. So for F1, I need to find its x component and y component, horizontal and vertical. So if I resolve this force, so this will be the y component, this will be the x component. So this will be F1y, this will be F1x. Here you can see that both component will be negative because the direction of this x component is on the left and the direction for the y component is downward. So both x and y component will be negative for the F1 force. So I will be applying for the x component cos theta. So directly F1x will be equal to the resultant times cos of theta. So putting the value of the resultant force, which is in this case, which is F1 for this two component, I'm saying the resultant force. So the F1 value is 700, cos of theta is 30 degree. So it is this is origin. So the direction of this force is on the left from the origin. So this component will be negative. So the value of F1x will be minus 606.2 pound. So this is the x component of this F1 force. Now for F1y vertical component, I will be applying sine theta formula. So it will be the F1 times of sine theta. So the F1 value is 700 and sine theta value is 30. So its direction is also downward, so it will be negative. So the F1y will be equal to minus 350 pound. So we found the value for the F1 force, its horizontal component, F1x and F1y. So these are the rectangular components, are the horizontal and vertical component of this F1 force. So I will be writing these F1x and F1 value somewhere on the left. So because I need for the Fx and Fy and finding the resultant in this direction. So I need all the components, individual horizontal and vertical values. So we did calculation for the F1. Now we will be doing calculation for the F2. For F2, which value is 400 pound. So I'll be resolving its x, finding its x and y component. So for this, you can see that from in the figure that this force directly acting along the y-axis and its direction is downward. So it means that it don't have any x component, horizontal component. It is directly acting along the y-axis, means downward, vertically downward. So it has only y component. So for F2, the F2x will be equal to 0, and F2y will be equal to minus F2. It is directly equal to this force. So F2y will be equal to minus 400 pound. So this is the x and y component for the F2 force. This is the vertical component. This is the horizontal component for this F2 force. Now I will be resolving F3 force, finding its horizontal and vertical components. So here we have this triangle. So now I will be constructing another triangle, large triangle, and means this is the resultant force. So I will be resolving the x and y component for this force. So then applying similar triangle technique, we will get the value of the horizontal and vertical component of the F3 force. So this is the resultant force. The y component will be acting somewhere here, and the direction will be downward, and the x component will be moving on the right, like on the x-axis, and its direction will be on the right side. So this will be the F3x, F3y. This is the y component, this is the x component. So here you can see that we have this one large triangle, big triangle, and one this small triangle. So we'll be applying a similar triangle technique to measure its x and y component. And also remember this for x component. Here you can see that it is the direction on the from the origin on the right side. So it means that it will be positive. The horizontal component of the F3 force will be positive because it is moving on the right side. And similarly, you can see that for the y component, its direction is downward. So all downward forces is we are taking those downward forces will be negative. Those forces we are taking is negative. So the y component for the F3 force is will be negative. So I will be resolving for this F3x. So for F3, I need to find its x and y component. The F3 value is 600 on. So I need to find its x component. So for x component, I will be applying similar triangle technique. So the base of large triangle to the base of small triangle will be equal to the hypotenuse of large triangle to the hypotenuse of small triangle. So this is the basic statement of similar triangle technique I told in a mathematical way. So for the F3x means the base of large triangle divided by the base of small triangle. Here you can see that the base of small triangle is 3. So its direction is on the left, on the right side from the origin, so it will be positive. So there no need to write positive sign. So base of large triangle divided by base of small triangle will be equal to the hypotenuse of small triangle. In my case, the hypotenuse is F3, which is 600, divided by the hypotenuse of small triangle, which is 5. This is the hypotenuse of large triangle, which is the resultant force 600, and this is the hypotenuse of small triangle, which is 5. So I will be doing calculation for the F3x. So shifting this 3 to the other side. So 600 divided by 5 multiplied by 3. So the F3x value will be equal to 360 pound. And now for the y component, I will be applying in the same way similar triangle technique, but in this case, I will be taking this perpendicular of large triangle to the perpendicular of small triangle. Like perpendicular of large triangle is F3y divided by perpendicular of small triangle, which is 4, equal to hypotenuse of large triangle, which is 600 divided by the hypotenuse of small triangle, which is 5. Now, what will be the direction? Since we already discussed that it's directly acting downward, so all downward forces we are taking as negative, so the sign will be negative, right, in this side or the other side, so it doesn't matter. So F3y will be equal to, I'm shifting this sign to the other side, so it will be 600 divided by 5, and also shifting this 4 because I only need the F3y value, so multiply by 4. So the calculation for the F3y, so it will be equal to minus 480 pound. So we already found the horizontal and vertical component for the F3 force, this force. So we applied here for the F1 force cos theta and sin theta, and for the F3 force we applied similar triangle technique. And for the F2 force, it is no need to apply the trigonometric ratio, it directly acting along the y-axis. So it means that we found the value for all three individual forces, their x and y component. Now I will be measuring the resultant horizontal force, and then I will be measuring the resultant vertical force. Then I will be applying the magnitude formula. Then we'll be solving for the direction. We found the x and y component of all these forces I have written on this side. So now I will find the fx, and then I will be finding the fy. So the fx will be the individual horizontal components of each force. So f1x plus f2x plus f3x. So putting the values of each force x horizontal and horizontal components, like for f1x, which value is minus 606.2, plus the f2 value is f2x value is 0. Then for plus f3x, its value is plus 360. So I will be adding all these to get the horizontal component, means resultant horizontal component. So its value will be minus 246.2 pound. So this is the resultant horizontal force of all these three forces. Now, similarly, I will be going for the Fy. I will be adding a vertical component of each force. So F1y plus F2y plus F3y. So I already found the value of F1y, F2y, and F3y. I will be putting F1y value is minus 350 plus F2y value is F2y value is minus 400. So plus F3y value is minus 480. So the Fy value will be equal to minus 1230 pound. So these are the horizontal component of the resultant force. This is the vertical component of the vertical force. Now I will be applying the magnitude formula, so then I will get the value of the resultant force. So we already know the formula of the resultant force, which is the resultant force is equal to the square root of fx square plus fy square. So I will be putting the value of fx and fy. So the fx value is minus 246.2 square, then plus the fy value is minus 1230 square. So putting the values in calculator, we will get the resultant force, which will be equal to 1254 pound. So means we solved one part of the question that required the resultant force. So this is the resultant force for this question. Means if we have these three forces, so the resultant of these three forces is 1254. So now I will be looking in this figure that where is the our resultant force is acting. So here we have this y-axis and we have this x-axis. Here you can see that x and y component both are negative. So this is the first quadrant, this is the second, third, and fourth. So we'll be now seeing that in which component both the horizontal and vertical are both value is negative. So here you can see that in first quadrant the x and y both are positive. Both are positive. And in second quadrant the x component is negative and y component is positive. And if we see the third quadrant, x and y both are negative. Here you can see that this is origin, and the this side is on the left, so this will be negative, and this side is downward, so it will be negative. So and fourth, the y component will be negative and the x component will be positive in fourth quadrant. But this is the third quadrant. Both the x and y value are negative. So it means that our force will be laying somewhere here. It lies here. This will be the resultant force. So its value is 1254 pound. So the x component, I will be drawing the x component of this force. So it will be the x component and the y component will be in this way. And also we know the fx value, which is minus fx is equal to minus 246.2 pound, and the fy value is equal to minus 1230. So now I will be determining this angle. I will be determining this angle. So I will be applying tan theta for this because this is base, this is perpendicular. So I need this angle. So I will be applying tan theta. So I am assuming this angle is alpha. This angle is alpha. So now I will be doing calculation for the alpha. So alpha will be equal to tan inverse perpendicular over base. Perpendicular is Fy and the base is Fx. So I will be putting the value. So tan inverse will be equal to the Fy value is minus 1230 divided by the Fx value is minus 246.2. So the alpha I got is 78.7 degree. So this is the calculation for this angle only. But in question, it says that measured counterclockwise from this x-axis. So it means that we need this angle. So we already found this angle. So we'll be just adding this angle, which will be equal to 180. Means if we add this 180 to this theta, we will be getting this angle. So this angle I am considering it as theta. So now I'll be doing calculation for theta. So theta will start from here and will achieve this resultant force. So this is theta. So theta will be equal to alpha plus means this angle plus this angle, like from this side, from this point to this, like half of the circle. So half of the circle is equal to 180 degree. So the main angle which is measured from this x-axis counterclockwise will be equal to 78.7 degree plus 180 degree. So the theta will be equal to uh, 258.7 degree. So it means that we found the value of this the resultant force and its direction. So this is the main step that if you understand this step, you can apply in many lecture. Like they require, sometimes they need that measured angle from this axis. Sometimes they need to measure the angle from this axis. So it's just mathematics. You will be playing with mathematics and calculating their horizontal and vertical components, and then by using your concepts, that how you understand the question. So we found the value of the resultant force and its direction. So I hope you got the whole concept behind solving this lecture. So thanks to everyone.